2.8, graph linear inequalities. In two variables. So I'm quite sure you've done these before. This is just basically graphing and shading. If it's just less than or just greater than, or is it solid or dotted? The line. Yeah, if it's just less than or just greater than, is it solid or dotted? Dotted. Dotted. If it's or equal to, so if it has the line under it, then it is solid. Okay, and we shade in the direction of the sign. I don't mind if you use like colors and stuff on this section, or like a highlighter to like shade. That's fine. All right, but the first problems, they give you basically a problem, and then they give you two ordered pairs, and they want to know if they're a solution to the equation or not. So number 4, y is less than or equal to negative 5x. And we have the points 3, 2, and then the point negative 2, 1. And so it's possible that one may work and the other one may not. They may both work. Neither may work. It just depends. And so all we need to do with this is plug in the numbers and see if it gives us a true statement. So for 3, 2, I plug in 3 for x, 2 for y. So 2 is less than or equal to negative 5 times 3. 2 would be less than or equal to negative 15. Is that true? No. So this is not a solution.
I don't know.
2 is not less than or equal to negative 15. And then the other one, negative 2, 1. 1 is less than or equal to negative 5 times negative 2. 1 is less than or equal to 10. Is that true?
Yes.
Yes, so that's a solution.
How is it less than or equal to, even though we know 1 isn't equal to 10?
Well, it's saying like the less than or equal to, we're putting in a specific point, but it's saying any number that makes this statement true would be. Because remember, we shade on those problems. So the whole solution set is anything basically that's like, it's going to be shaded below. So this would be anything like in the bottom of that graph would work. So yes, technically we just know that 1 is less than 10, but for the problem it technically, if it was or equal to as well, like if we had gotten 10 is equal to 10 or whatever, it would have also worked. All right, let's graph some. So pretty much, if you know how to graph in general, the only thing is shading and making sure you shade the right direction, and if you can keep up with solid and dotted. So 8, x is greater than or equal to 6. So, draw my graph, and if you want to use graph paper, always welcome to, but you don't have to. So then, all right, so where would this be? How would I graph just x is equal to 6? Disregard the sign at the moment.
You go on the line, like the x-axis and that's 6.
Okay, so at 6 on the x-axis, so that's here. Okay, apparently I can't draw a straight line. That's nice. There we go. Now, it's solid because it's or equal to. And then x is greater than or equal to 6. So that means that anywhere that x is bigger than 6, I would shade. So I'm going to be shading over here. And so anything in this highlighted area would be a solution. So anything bigger than or equal to 6 would be a solution. 12. Y is less than 3x plus 3. All right, so I have an intercept at 3, slope of 3, so up 3 over 1, or down 3, back 1. Is this solid or dotted?
Dotted.
Dotted, because it's just less than. And then y is less than, so I would shade where?
The bottom. The top.
The bottom.
That's not.
Bottom. So it's where y is smaller than that. So that's going to be anywhere down here. And if you're ever not sure, you can do like what we did up here and pick a point on the top or a point on the bottom and plug it in and see if it works. So we can plug in 0, 0. So 0 is less than 0 plus 3. So 0 is less than 3. So I know that that area works. Okay, so you could just pick a point below and a point above if you're unsure, and it will tell you right away which way you're supposed to shade. 14. Y is greater than or equal to negative 2/3 x minus 2. All right, so I've got an intercept at negative 2. Slope of negative 2 over 3, so it's going to be down 2, right 3. Or up 2, back 3. And is it solid or dotted? Solid. Can't draw a straight line though today apparently. Good enough. And am I shading above or below? Y is greater than or equal to. Above.
Did we do this last year?
You may have.
Last year?
Or in algebra? I don't remember.
We did.
It's possible you did it in geometry, but probably more likely in algebra. Alright. 16. This will be our last one unless y'all feel like you need to see more. X plus 4y is greater than negative 12. So what do I need to do with this one?
Move the x over x.
Move x over. So 4y is greater than negative x minus 12. And what?
Divide by 1/4.
So y is greater than negative 1/4 x minus 3. And don't forget, because this confuses people a lot, when you multiply or divide by a negative still with these kind of problems, you got to make sure you change the inequality sign, because that'll change where you're shading. So alright, so intercept at negative 3. Down 1, right 4. Or up 1, back 4. And solid or dotted?
Dotted.
Dotted. Alright, and now y is greater than, so am I shading above or below?
That's it.
Above. Up here. So, y'all good with these? Remember? I would say if you, just for reference, if you don't have highlighters or something and you want one, let me know. But if you don't and you're gonna shade with these, it's not as big of a deal, but I would just do something like this if you don't have that, so that it's pretty evident, or like get a different color pen or something like that to do it with. It's not in this chapter, I don't remember what chapter it is off the top of my head, but when we get to the problems where we're solving like multiple equations and we're graphing like multiple inequalities and finding the solution where the overlap is, okay, you're going to want to have different colors when you go to shade those so that you can see where the solution is. So with this section, since you're only graphing one line and shading in one direction, you don't really have to worry about it, but anyways, just for reference for the future, you are going to want multiple colors when we do that. Probably like, I think the most we graph is 4 lines, and I always have different colors if you want them. But all right, problems then are not a lot, just 9, 11, 13, and 17. And if I'm not going to require it, but if you want one to practice of plugging in the numbers like we did in the first one, you could do number either 3 or 5. Just to see about plugging a number in, but you don't have to do that.